So when you solve a right triangle, you're finding all the missing pieces. They have to have two pieces of information given to you. Always start by identifying those two pieces of information. Draw your picture, and these are the two pieces of information that are given to us, 3 and the 4. That's going to be significant because when you're solving this triangle, you always want to use the two pieces of given information. And we'll talk about that a little bit more as we work through this. What do you want to find first? C, right? 3 squared plus 4 squared is C squared. 3 squared plus 4 squared is 25, which means C is equal to 5. It's the 3, 4, 5 right triangle. It will come from the Pythagorean theorem. Okay? Now, let's find angle A next. It doesn't matter which one you find next, but let's find the angle A. So I've got A, and I've got 3, and I've got 4. And this is where I'm telling you that it's important to use the pieces of information that were given to you. We know 5 is correct, so it would be okay for us to use 5 here. But if we were solving for something and this was some kind of other value or a decimal value or something like that, it's just better to use the given pieces of information so you don't compound any mistakes that you might have made along the way. All right, so what is the relationship between angle A, 3, and 4? Opposite over adjacent, right? So this is the tangent ratio. So we're going to use the tangent of angle A, or you could use the variable theta here. That's the Greek symbol theta. Tangent of angle A is equal to 3 over 4. And then if you remember back to your geometry skills, we're going to go a lot more in depth on this at a later date, but tangent is A is the angle or inverse tangent of 3/4. I don't know why I put that negative there. Because I've been out of school for a week. Tangent of 3/4. And then on your calculator, what is the inverse tangent of 3/4? Inverse tangent of 3/4 is what? 36 point. 8699. All right, we'll just do one decimal place here. 36.9 degrees. Okay. So we're saying that A is 36.9. All right. Now let's find angle B. How could we find angle B using what we've solved for? Do what? You could subtract it from, or you could just subtract it from 90, right? We could just subtract this from 90 because one of our 26 right triangle facts we over here with is angle A and angle B are always complementary. Those two angles have to add up to 90. But again, the danger there's a lot of dangers there. Rounding your decimals incorrectly. You miss 2 problems instead of 1 problem. So if we use trig to find angle B, if we use trig and just the information that is given to us, what would we do? Again, we're going to be dealing with the tangent relationship, right? Because we have the opposite side over the adjacent side. You getting this, Cherry? That means B is the inverse tangent of 4/3. Which means B is approximately how many degrees? It comes out right, doesn't it? 53.1. So B is 53.1. right? Now, once you have solved the triangle, we've got all the missing pieces. You have a close look at it. Does this triangle make sense? Do the values that we put in here make sense with what we know about a right triangle and triangles in general? What are some things you can look for? Do the angles add up to 180? Great fact. And they do in this one, right? So that's good. What else can we look for? Is the smallest side opposite the smallest angle? Right? Is it? 3 is the smallest side, and 36.9 is the smallest angle. Right? Largest side is the hypotenuse. And so this triangle makes sense. All right, test 1 has a few triangles on it. Test 2 is all triangles. Just solving triangles and word problems related to solving triangles. Okay, so always ask yourself the question, does my triangle make sense? Draw the picture, label the picture, does it make sense? Some of you are going to make mistakes on the test, and I'm just going to write right next to the triangle that you've drawn there, does this triangle make sense? And when you look back at it, you're like, oh, this can't be right because the smallest side's not across from the smallest angle and vice versa. So just learn to ask yourself those questions. Okay, let's have a look at this one. It's a similar one. We just have 3 or 4 examples today and a short homework assignment. Getting back into the picture. It's easy too. Okay, draw your picture. Identify the given information. What are we given? These 2 pieces of information. We're going to use those 2 pieces of given information to find everything. All right? What do you want to find first? B. 5 squared plus b squared equals 13 squared. That's going to be b squared equals 144. 169 minus 25, so b equals 12. B equals 12. Okay. Let's find A next. So we got the 2 pieces of given information we're going to use to find angle A. What's the relationship we're going to use there? Sine of A is equal to 5 over 13, which means A is the inverse sine of 5 over 13. So we get an approximate value of A. What's our approximate A value? 22.6. Now again, it would be okay at this point to just subtract that from 90 degrees to find that other angle. If we were in a hurry, it would certainly be wise to do that. And you'd get 67.4, right? Let's choose trig to find it, just because we're using only the given information. So if we're using trig to find that, the 3 pieces of information that we have circled there now tell us to use which trig ratio? Cosine of B is 5 over 13. Again, we see the cofunctions are working the way they should. Sine, cosine, assign equal values to complementary angles. B is equal to the inverse cosine of 5 over 13. And we're going to confirm that B is actually 67.4 degrees. Always label your triangle. Always make sure that your answer makes sense. Is the smallest angle across from the smallest side? Is the largest angle across from the largest side? Do the three angles add up to 180? You know, just a quick check. All right. Next example. What's different about this example and the previous ones? They give us an angle here instead of two sides. So here we have an angle and a side. So again, very important. Sketch it, make sure you identify the given information. That's the two pieces of information we're going to use to find everything else. Now in this case, the easiest thing to find is angle B. And since 34 is given to us, it is absolutely the best thing to do is just subtract 34 from 90, because we know that angle A and angle B are always complementary in a right triangle. So that piece of information is practically given to us now at this point too. 56 is there. All right. Well, let's find B first. Little b, side B. And you see how, you know, when you identify those things, it's a little easier to see the trig ratio that comes into play. What trig ratio is in play here with 34 degrees, 2, and B? What trig ratio? Don't go quiet on me. Do what? What's the trig ratio that relates 34 degrees, 2, and B? It's opposite over adjacent, which is tangent, right? The tangent of 34 degrees equals opposite over the adjacent. Now, this is difficult for people. This is a proportion. If you put tangent over 1, and then one of the properties of proportions is that we can just flip-flop the means or the extreme. We don't have to cross-multiply every time and do the whole, you know, cross-multiply and then divide. You can just swap the 2 and the B. So you can just swap these. It's one of the properties of proportions. So we can swap those two pieces and we get B equals 2 divided by tangent of 34 degrees. And B is approximately how much? Let's keep 2 decimal places. Somebody just said 3. Yeah, 2.97. All right. What's the problem with rounding that to 3? What's the problem with rounding that to 3? If the units were miles, is there a recognizable difference between 2.97 miles and 3 miles? There is. I mean, it's significant. It's several feet off, right? If we're talking about light years, there's a huge difference between 2.97 light years and 3 light years. Okay, so in trig, you have to always err on the side of keeping decimal places. Now, let me ask you this question. Now that we know this leg and this leg, could we switch to the Pythagorean theorem to find the third leg? Should we switch to the Pythagorean theorem to find the third leg? What's the problems that we could run into if we switch the Pythagorean theorem to find the third leg? The same thing we just mentioned is one of the problems, right? 2.97 squared. Well, it wasn't 2.97, right? It was 2.9 something that we rounded to 7. Okay, so we're automatically messing ourselves up from an accuracy standpoint. If we use if you were going to use the Pythagorean theorem, you would want to have 3 or 4 or 5 decimal places instead of 2 decimal places. So let's don't use the Pythagorean theorem because it's a little messy with that many decimal places anyway. Let's use trigonometry to find C. All right. So what is the trig ratio that relates those 3 quantities, 34 degrees, 2, and C? What trig ratio is that? Sine of 34 equals 2 over C. Cross multiply, use the property of ratios, proportions there. We can just swap the sine of 34 and the C equals 2 divided by the sine of 34 degrees. 2 divided by the sine of 34 degrees gives us a C value that is about how much? Say it again. 3.58. Okay, so it's approximately 3.58. Okay, let's have a look. Does the triangle that we solved here make sense? Is the smallest side across from the smallest angle? Largest side across from the largest angle. Now you could at this point use the Pythagorean theorem to make sure that 2 squared plus 2.97 squared is somewhere in the ballpark of 3.58 squared. They wouldn't be exactly equal because of the rounding, but you could also do that to check if you'd like. All these right triangle facts that we have written here we can use to make sure that this works. Okay? That's going to be it. We'll stop there.